Welcome. Let's solve Leetcode 2948. Make lexicographically smallest array by swapping elements. All right, let's make this thing bigger so we can read it. But you're given a zero index array of positive integers and a positive integer limit. In one operation, you can choose any two indices, I and j, and swap them. If their absolute difference is less than or equal to limit, return the lexicographically smallest array that can be obtained by performing the operation any number of times. Okay, and for example, the array, sorry, and array A is lexicographically smaller than array B if in the first position where A and B differ, array A has an element that is less than the corresponding element in B. For example, the array 2, 10, 3 is lexicographically smaller than the array 10, 2, 3 because they differ at index 0 and 2 is less than 10. All right, let's go over example 1 here. So they give us numbers 1, 5, 3, 9, and 8, and they want us to swap, or if we can swap them because two values are within the absolute difference of the limit, go ahead and do so. So in this case, this 1, 5, and 3 are all within the absolute difference of 2, so we can shuffle them around so that we get 1, 3, and 5. And 9 and 8 only differ by 1, which is less than or equal to 2, so we can swap them around and we get this expected return value. All right, moving on to example 2. We can swap this 1 and 2 because they, sorry, do we even need to? No, we can swap this 1 and 2 because they're less than 3, so we get this here. We can swap this 7 and 6 because they're less than or equal to 3, so that is done. So that's how we get this here. So 1, 6, 7, 18, 1, and 2 is the expected return value. Okay, example 3 is very similar, so I do not feel it is necessary to go over it. All right, cool. I think the approach I will go over here is quite different than the other ones, and it will be very fast. So that's good news. All right, cool. Let's get started. I actually recorded the video and then somehow deleted it. So sadly, I have to do it again or do my work twice. No problem. So let's do it. So let's go over this first example here. We're given 1, 5, 3, 9, and 8. Let's move this to the side and make this bigger. So what we'll do is our first step will be to sort nums into this here. Sort nums into n, so that we're given this and we get this. And it's just sorted into a temporary new array. And then what we'll do next is we'll loop through the sorted array or sorted list and find where the absolute difference is beyond the limit. Okay? And when we come upon a group, when we come upon a pair of numbers that is outside the limit, we'll start a new group and we will store the new location. Okay? And I guess we'll store the starting location for every group. All right, so I know some of it may not make direct sense, but I will come back to this example as we implement the algorithm, or we implement our solution. All right, cool. So let me just start off with some of the easy stuff. So I will use the length of the array or list quite often, so let me store it here. So let's use length of nums, and let's sort nums. So sorted nums. Okay, so I haven't done anything too advanced here. Just got the length of the of the list and sorted nums into a new array. So now we're at this point here. Now let's move on to step 2. So we'll compare each pair of numbers to determine if they fall within this limit. Okay, so let's do a little bit of a trick here. So a small trick. So I'm going to say for maybe I in range 1 to n. And what we'll do is we'll compare the numbers. So we'll say if n at I, or n at I is the difference between the one before it. And so since I'm starting at index 1, I don't need to worry about an out of bounds issue. So if this is bigger than the limit, this will be assigned to a new group. So if we think about it, for example, like these 1, 3, and 5 are in one group, and this 8 and 9 are in a separate group. Okay, so and the reason being is that all of these numbers, like 8 and 9, fall within the limit of 2, like absolute difference of 2, and 1, 3, and 5 fall within an absolute difference of 2 as well, but separately. Okay, so if we get to this point, well, what does that mean? That means we have a new group. So let's increment our group count, and then we'll store this group location start. So we'll say group start dot append I. So now what do these represent, and let's initialize them. So our first group, well, let's figure this out. I'm going to store something here. I'm going to call this numbers to group. So every number will be assigned to a group. And it should make sense that the smallest number in our group will start at group 0. So we'll say n of 0. That's the smallest number. It'll start at group 0. And we'll say group, and group start equal. So the first group would be 0, and the group start will be at index 0. Okay, and don't worry, I'll print this out in a moment so we get a visual of what, or a visualization of what has happened so far. Okay, so once we know that two numbers do not fall within the absolute difference of the limit, we start a new group and we store that starting location in our group start list. But nevertheless, we need to add that number to our number to group, like our map. So we know which number belongs to which group. So we can say, okay, so number to group, that number equals the group. Okay, let's print out what we have so far. So let's say, okay, let's print out our sorted numbers. Let's print out our number to group, N2G, N2G. And then let's print out maybe our group start. So print group start, group start. And then for now, let's just return nums so that we don't, just so that we don't get an error. So let's test it. My apologies, what went wrong here? Oh, silly rabbit. Okay, so what do we have here? So this is the sorted list of numbers, and this was the original list of numbers. Now we know what each number belongs to. So 1 and 3 and 5 belong to group 0, and 8 and 9 belong to group 1. And these will be our starting locations. Okay, so okay, and let's move on maybe to case 2 here, just to get another visual. So we know there's 1 and 2 belong to group 0, 6 and 7 belong to group 1, and 18 belongs at group 2. and these will be our starting locations for each of the groups. Also notice that that since our limit is 3, 1, 1, and 2 would be, in a sense, it would be like its own component in a graph. And 6 and 7 would also be in a separate component, and 18 would be in its own component. So notice how we have 3 indices here. There's some kind of relationship between that and the number of groups start locations, or groups as well. Okay, so going back to our implementation. So now, how do we use this? Okay, so what we're going to do is we're going to maybe initialize an empty list here. And before I forget, let's return that here. So what are we going to do next? Let's do this here. Let's move this up. And then we'll loop through all of the numbers in the original list. So we'll say for I in nums. And this is the original list that they gave us. And we're going to, so this is the actual value of the number. So let's figure out what group this number belongs to. So we'll say G equals, we know we can use this number to group to figure out what group this belongs to. So N2G of that number. So this is the group it belongs to. And now we know where this group starts at. So remember, this group start, we know where it starts at. So we'll put it there. So we'll say, okay, so result.append, and we'll say the number and what is it? Group start. So group start, and then that's the group it belongs to. So this is kind of tricky here. So for this first example, let's see if I can pull this up a bit. So our original number was, so if we're looping through this here, so I in nums here. So I is 1. Okay, so then we say, okay, 1 belongs to group 0. Okay, cool. And then we say, okay, so then we go to group start. So then group start, so is 0, so it starts here. And then we say, okay, let's put 1 here. Okay, fine. So then that makes sense because it's expected that 1 should go there. Okay, but what we're going to do though is that we're going to increment this. So we're going to say, okay, we're going to say so group start at G plus equals 1. So what does that mean here? So that means when we're looking at this now, so even though it still belongs to 0, we're going to change this 0 to a 1. So we're going to be incrementing where group 0 is placed. So it's still part of group 0, but it starts now at index 1. So let's print it out as we move along. So we'll say, okay, maybe let's print. So let's print our number maybe. So let's print. Let me move this down. So print. So I will be I and group will be G. Okay, and then we'll do something like this here. Maybe this will be group start. Group start. Let's just print it out. Okay, so let's try this out. Okay, so what do we have here? Okay, so our first number is 1, and we know it belongs to group 0. And these are our group start locations. So once we place 1, and remember 1 is at group 0, so we increment this. Then we go to 7. 7 belongs to group 1. So group 1 is here at this location, 3. So we place 7, and then we increment the location. So actually maybe we should print result along the way. Let's also print result. How about that? Okay. Okay, great. Let's move this down. So notice so far, just to be clear, that we have the correct answer, but let's see how we got there. Okay, so this is our sorted numbers. This is our original numbers. And well, let's see how we got there. So remember, right now, the key part is, let's maybe move this down a bit. The key part is this part here. So we're looping through the numbers. So we loop through the numbers, and then we say 1 is our number, and it belongs to group 0. So we figure out, well, where does group 0 start at? Group 0 starts at 0. We place it into our array here, and then we increment it. So now this was 0, and now it's 1. Then we move on to the next number, 7. 7 starts, well, 7 is a member of group 1. Group 1 is at, well, originally it was at index 3, but then we index it, what do we do? We increment it 4. Now the question is, well, why is 6 here? So what we do there, and this is the reason why, because remember, we're not placing I. We're not adding I to the results here. We're adding the first member of the group. So I hope that makes sense. So like, let's see. So for example, so let's look at this here. So what do we do here? So like 3 here, 3. Well, what does this represent? So let's look at this here. So 0, 1, 2, 3. That's this here. I hope that makes sense here. So then when we increment this is now, so we increment this, now this becomes 4. So this is 0, 1, 2, 3, 4. So that's why what we're doing. So it's very misleading that we're not adding this number. It's like a lot of misdirection. So this is more of like this group start of, this indicates where to start in the sorted array. So I just want to make that clear. These indicate where to start from the sorted array. And then we increment them. Okay, and then moving back, so then going back, so then after, so once we place, so we're at 7, then we move on to 6, because 6 is the next number in the original list here. 6, so 6 is a part of group 1. So then we say, okay, we go to group 1, and then we say group start of 1, but group start of 1 is 4. Remember that? Because it's 4 right now. So we go to these numbers here. So we say 0, 1, 2, 3, 4, and that's 7. So this gets appended to the result. So if we look at result here, it's 167. And next, as we loop on or continue the loop, we see 18 here. So 18 is a member of group 2. Okay, so then we say, okay, so we go to group 2, which is 0, 1, 2, which is this here, which is 6. Sorry, well, it's 5. It's 5. So then we go 0, 1, 2, 3, 4, 5, which is 18. Okay, so then we say, okay. And then, so this one happens to be that one, so it gets added. And then we increment this. So now this becomes 6 now, because it was before it was 5. Okay. Then the next value is 2. for 2 we see that it belongs to group 0. For 0 though, this index points to what value in the sorted array needs to be added. Sorry, but I apologize. So right now it's, what is it? It's 1. This is after, I should have printed it before. But right now it's at index 1. So that's why at index 1 we go, okay, that's 1 here. So that's why this 1 is added. And then if we carry on, well, let's just continue on. Then we go to 1, 0. Then we check, okay, 1 belongs to group 0. But group 0 is at index 2 right now. Oh, is that right? Let me see. 0. Yeah, that's right. 0, 2. So then we go, okay, so 0, 1, 2, which is 2. And then that gets appended here. Okay, I know it was very tricky and a lot of misdirection, but this is what allows our code to be super fast. So let's remove all of the print statements. Well, let's just submit it. Let's see how, well, let's take them off because it might cause an error if we leave the print statements here. Let's submit it. Okay, so notice how it's very fast because remember the fastest time is 137 and we're 138. So it's because of this fantastic misdirection and we don't need to do anything very complicated because I know some of the other approaches use sorting and we only sort once. We just sort once here, but we don't need to sort. There is no embedded for loops here. There's no embedded for loops and additional sorting because some other algorithms or approaches use sorting within a for loop. So it just made the entire time complexity far greater. So for our time complexity, the worst case we have to worry about is the sorting here, which is O of n log n. But other than that, this is O of n and this is O of n. So for the most part, it's pretty quick. And so that's about it. I know this was complicated and there's a lot of misdirection, but that's what allows our code to be fast. If you would like to see a simpler version where there isn't so much more what's the word, like craftiness, because I did another approach where it's a little bit more straightforward, but it wasn't as fast. It was maybe about, I think, 400 milliseconds, but this was the best approach that I came up with. Okay, if you found this video helpful or beneficial, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself. Cheers.